So we're talking about the second problem from our homework for this week, okay, guys? So the formula for exponential decay is still the same formula as any exponential growth. We're going to explore actually why that is in a little bit. So first things first, though, in this first part, it tells us that atmospheric pressure decreases by 12% every 1,000 meters above sea level that you are. So um, what that means is that like if I were to travel, if I was to climb a mountain, right, at sea level, my atmospheric pressure is 1013 HPA, right? But then as I go up the mountain, right, here's 0 meters, here's 1000 meters. As I go up the mountain, the air pressure decreases. So here, my air pressure is going to be smaller. So the question is, what would be the pressure? Well, if it's decreasing by 12%, that means that we're going to need to multiply this. We're going to need to multiply this value of 1000, our starting value, by 12% less than 100, right? Essentially, if I multiply this by 100%, which is 1.00, I would get 1000, right? Because that's 100% or I mean, not 1000, sorry, 1013 I should be using. However, if we've traveled up 1000 meters, then this would decrease by 12%, right? So what we're going to get is the starting pressure times actually 0.88, because 88% is 12% less than 100, right? So if I do this with a calculator, I'll be able to know what that value is, right? So let's go ahead and I just need to pull out a calculator really quick and type in 1013 times 0.88, and I get 891.44. So what that means is that the atmospheric pressure here at 1,000 meters above sea level is 891.44 HPA. And HPA is just a unit of measurement for atmospheric pressure, right? So that's how basically what we're doing here. The reason why we're solving for this is that it's going to allow me to calculate the growth rate, right? If I have 2 points of interest, right, I have my starting value, which this guy's my starting value, and then I have some later value, right? Then I can use the two of them with my exponential growth formula to calculate that rate. So let's go ahead and try and apply it, right? So in our growth formula, right, we have f of t equals a e to the rt. A here is always your starting value. The atmospheric pressure that we started with was 1013, right? So we're going to have that as our start. So we have 1013 times e. E is just a number, right? To the power of r. We don't know what the rate r is, right? So let's leave that as the variable. And so then now the question is, what do we do with t and f of t, right? This is the whole reason why we calculated this value here, right? We can plug in 1000 for the time. It's an abstract idea, right? But while we usually use time to talk about exponential growth, but in this one, instead of time, we're actually talking about how high up above sea level you are, right? So we're going to plug 1000 in here, and it should be equal to whatever the atmospheric pressure is at 1000 meters, which we calculated to be 891.44. So what we can do now is if we solve this equation for r, we will know the growth rate and be able to derive our exponential decay model, right? Um, at this point in time, I think you guys could do it. So I want y'all to, if you're watching this as a video, I want you guys to pause it and try to solve for R. Now, for those of us here live, I'm going to do it right now. So we would divide both sides by 1013. And we need to calculate that, right? So let's pull back up our calculator. That gives us actually 0.88. Oh, and isn't that interesting, guys? We got 0.88 back because if you think about it, right, the pressure at 1,000 meters above sea level was supposed to be 12% less than what we started with. So actually, we end up getting 88% as the ratio between them, right? So 0.88 equals e to the r times 1,000. In order to remove this e here, we got to use natural log on both sides, right? Because natural log is the inverse of e to a power. Those cancel each other out. And then we get that the natural log of 0.88 is equal to r times 1,000, which is simple enough to solve for, right? Divide both sides by 1,000.
Brothers. Oh, sorry.
the fun effects of live teaching.
Who was that, Glenn?
No, please. Okay, so in the end, we got the natural log of 0.88 divided by 1,000. Let's calculate that with our calculator. And the answer we get is actually extremely small. So we get r is equal to negative 0.0000. Oh wait, not 4 zeros, only 3. 127. Oh, that 7 should round up to an 8. So that's what we get for our growth rate, which can then be plugged into our original formula, right? So we get that the pressure, I'm going to actually change this to P of H, as in pressure at height. So the pressure at any given height is going to equal 1013, our starting value, times E to the power of our rate, negative 0.000128, times the height. And that is our formula for calculating the pressure at any given height above sea level.